All right, so let's okay, let's any message for me. Good morning. All right, let's start the lesson. So everybody can see the screen. Okay, so this I'm going to look at the last section of this navigation. So we're going to do major calculation now. The most important calculation in this chapter will test you in the exam, right? Not MSc. MSc will stop at law of sine and law of cosine. Okay, so what is it about here? Let me show you. This is about the model of the Earth now. The ship is moving along the Earth now. So usually the ship will try to move along the great circle. Okay, try as much as possible to try to move along the great circle. So over here, you see that we have North Pole. So North Pole here. So I denote that. We use P for North Pole. So our notation, P is North Pole now. North Pole. Of course, there's a South Pole also, huh? Okay, then I say the ship going to move from point A to point B and travel along the great circle. A great circle is a circle pass through the center of the Earth. So you can see that the point A here, the point B here. So we'll move along from point A to point B. So this is a path highlighted here. So I use a blue color here to show you that this is the way you're going to move here. Okay, now you look at the connection from P to A along the great circle. So actually, this is actually here pointing toward the north. Okay, from A to the North Pole, so this is pointing towards the north. So normally we draw a picture in a plane. You see, oh, this is the north here. Okay, this is north here, and then this is the point A. Okay, so you see that this is north in the direction pointing towards north, right? So this is North Pole here now, which is at pointing north here. So the angle alpha show that the angle alpha show that is the direction of the ship heading to. We call it initial course. So this angle alpha, okay, is actually this angle. The ship trying to move to direction. So this angle alpha here. Okay, so direction, and this alpha give you the initial cost. So we call it the alpha is the initial cost. Okay, so this is the direction the ship trying to move. Okay, from measure from the North Pole. Okay, then here, okay, so actually initial cost, you can see the direction, it move this way. Okay, move this way. And then what is the final cost? Okay, at the North Pole. So there's the final cost. To the North Pole here. So the direction move now is this one called beta. So you can see that this is the direction the ship trying to move also. Measure from the North Pole. Okay, measure from the North Pole here. So this is North Pole here, and the direction is called beta now. So this is actually beta. Okay, so this is actually the final cos, right? Just now we call alpha, now it's called beta. Okay, this is alpha, this beta here. Beta, if we name for this, it's called the final cos. Okay, beta, final cos. So that as we move join to the north pole, right, so it's actually a triangle. And the triangle actually looks something like this, right? The triangle here. So this is the portion of the triangle here, actually for the movement. So actually is a triangle, spherical triangle. Right? So this is a portion we are actually focused on. So you can see that, okay, now alpha and beta, both of them are measured on a north pole, right? And then the angle A and B, so this is a B here, B is here, okay? B is here, and shipment, the ship is trying to move and measure the direction from the north pole. Okay, so this is a big application that you see in a big picture here. Okay, so I need to explain a little bit some of the terms over here. So you can see the focus on the big triangle there. Now, from this picture, let's look at the yellow triangle first. The distance PA, right? What is the distance PA here? Or we call it the side PA. This distance PA is the side PA here. We have name for this. It's called the co-latitude of point A. Okay, co-latitude of point A. Look at that PA here. So in yellow triangle. So and let me use. Look at this triangle again. So I can do one at a time. So the distance PA, which highlighted here, okay, is this portion here. Okay, we have name for this. It's called the co-latitude of A. Okay, the side PA here. Okay, co-latitude of A, right? So it's the length co-latitude of A. Of course, we can also talk about side PB. That we call it co-latitude of B. Okay, so measure PA and PB, and usually we take note that this is the direction toward the North Pole. Okay, toward North Pole here. Okay, the ship move from A to B along the great circle. So this is the path. Great circle here is a circle path to center of the Earth, and this direction called the great circle distance between A and B. All right. Now, how do we we talk about initial great circle cos and beta. We already mentioned alpha and beta. Now, what is the angle P in this case? Okay, angle P is actually, you know that the point A and B have a longitude, right? Right? Longitude and latitude. How about that? Latitude earlier. Okay. So now the P, angle P, this angle P here is equal to difference between the longitude. Okay. Angle P is between the longitude of A and B. So this is the distance angle between the longitude of A and B. So A has a longitude, B is a longitude. Find the difference between them. So that is the difference between the longitude of A and B, angle P. Okay, so this is more or less the picture of the spherical triangle. Now, there is also one thing called the vertex. The vertex here, as the what is the vertex here? Let me use the orange color here. Vertex here. Okay, what is the vertex here? Vertex is a point on the great circle distance from A to B, which is nearest to the pole. Okay, nearest to the pole. So when it's nearer to the pole, that means that if I erase all the color, okay, erase all the color also, the point nearest to the pole somewhere is here. So somewhere here, this is V here, vertex here. Nearest to the pole. So drawing the North Pole to B. So because this is nearest to the pole, and then of course nearest means this angle must be 90 degrees. Okay. And so PV, right? V is a point nearest to the pole. Because there are two ways depending on where the pole is. If the pole is north, then we call north vertex. Okay. So if the pole is on the south, then we call it south vertex, right? So vertex of the pole, the great circle exactly 90 degrees or 270 degrees, true bearing, forming a right angle with the meridian. So actually, we join P to V there, okay, and that angle is 90 degrees. Okay, one of the possibility. Okay, the understanding of vertex, nearest point to the pole. The nearest point to the pole could be nearest to the north pole or nearest to the south pole, depending on where the ship is heading. So to give you the introduction of the situation here. Okay, so we're going to look at example now, right? So let's see what example. Let's see how it will now. So example, so now 22 of you inside there. Some people not here yet. Okay, there 5 of you not here yet. All right, let's come back to the lesson. So we're going to look at example 9. So I'm trying to get example 9, okay? We're going to start from here. And then you're going to draw a lot of picture. So let's look at the statement first and see how the statement goes. A ship leaves a point, position A, 25 degree, 31 degree north, 60 west. Okay. So this is the ship here. Let's call this point A here. Okay. Let's call this point A here. So this is telling you where it is moving, leaving this position. So let's see, just use a color to show you. So this is moving this position. And follow a great circle track. The initial course is 68 degrees at A. The last one moves 68 degrees through bending. Find the latitude and longitude of the north vertex. So they want to find the latitude and the longitude of the north vertex. This is what they want. Okay, so let's try to understand the question. I'm going to draw some big circle here, highlight what's going on here. So let me draw a sphere first. So this is the Earth here. Okay, so this is a North Pole, P. Okay, somewhere you have a point A on the left west side of the Earth here. So this is equator first. Okay, this is equator. Okay, I want to find out what is A here. So let me say this is the west side now. So west of this is let's say I'll put a sample here, and this is 60° west. The line 60° west, right, on the west side of the Earth here, and then longitude, the latitude is 25°, 31 minutes. Yeah, so let's say it's this center of the Earth here. Then you go look at this point A. This point is A now. The angle for the center of the Earth is 25°, 31 minutes. So let me use a title. Okay, 25°, 31 minutes. Okay, I hope you can see that. Okay, 25°, 31 minutes. Because I think the marker is very fine. So we get 25, 31 minutes. So this is the point A. Although the angle, actually, I have a quite big angle here. And you follow the track 68°, follow the track there, 68°, yeah. So this is a A, so follow to the North Pole. So you want to move along this direction to somewhere. Let's say, I don't know where is it. So this is direction now, 68°. Okay, somewhere there's a point B. That's the point B. I don't know where is it, because it didn't say mention, but you know this somewhere in the point B here. You can move along there. Okay, I want to find the vertex. Find the latitude of north vertex. North vertex means nearest to the North Pole. So you can draw from here to here to the point is called B here. And then go to the South Pole. Okay, this is the point, the north vertex. Okay, I want to find the longitude and latitude of the north vertex here, because this is 90° now. This is 90°. So I need to find out what is this angle here. What is this angle here? Measure from the center of the Earth. Okay, I want to know what is this angle here. This angle is called the latitude, right? If you know the angle from the center of the Earth of V, you know this is called latitude of V. So this is what we want to find. Okay, so I will draw a picture for you already. So let's look at the triangle we have here. this one. Right. So we've got a picture how everything goes. So usually, how do we start? Okay, usually I will try to find out this what we know about the triangle here. All right. So first, let's try to figure out what is PA first. PA is called the co-latitude of A. PA, right? PA. What is PA now? Okay, we know that the angle between P and equator, right? P and equator is 90 degrees, right? So latitude of P, co-latitude of PA, side PA is 90 degrees because the degree angle between North Pole and South Pole is 90 degrees. Then the angle between equator to A is 25 degrees, 31 minute here. This is the okay 90 minus latitude of A. This will give you the distance between P and A, right? So this is actually this is called the co-latitude of A. So you subtract them, you get 64 degrees, 29 minutes. This is called the co-latitude. Okay, co-latitude of A. So this is co-latitude of A. Okay, so I have PA, get up early, and I know angle V here, 90 degrees. So that's right. So now let's try to draw a triangle now, right? I'm going to use a Napier rule now because we are right angle triangle. Use a Napier rule. To find the rest. Okay, Napier rule is very useful. Yeah, right angle triangle. So I'm going to redraw this right angle triangle to here. Staggered right angle triangle, right? So let's go back to this page now. So I'm going to draw this right angle triangle here. So this is P A, and this one the direction it moves is 68 degrees, and PA we calculate just now is 64 degrees 29 minutes here. Okay, this V here, the vertex. So we're going to use the Napier's rule. Okay, so Napier's rule, you have to travel from toward 90 degrees. So V here, then AB, vector A now, and then this. Okay, so let's draw the Napier wheels. So Napier wheels, on top there are two portions. bottom the three portion. Okay, and then this V 90 degree. So going towards V 90 degree is PV. Right? Going towards 90 degrees PV. Then moving away from 90 degrees is VA. Then the angle A, which is 68 degrees, we know already. Then the PA. PA we know is 64 degrees, 29 minutes. Then the angle P, which we don't know. And then there's the COM in the middle. So obviously we have come to a conclusion that we can find PV first. So I use the color code here. So you have PV first. I use PV yellow light. Let me try this one. PV yellow. And then we green. So using the Napier's rule, right? So opposite of A and PA now. So you can use the Napier's rule now as right here. Sine of middle part here. You always put the unknown you want to find in the middle part. So sine of middle equal product of cosine, right? Product of cosine of opposite. So I think I need space here. Let me put in somewhere here. Sum of product of cosine of opposite here. So at sine of PV now, sine of PV, which is I use a green color one. All right, so this is equal to cosine of product cosine, right? So this cosine of COM A. Okay, because of the lower half, and cosine of COM PA because of lower half here. Okay, then we know that, okay, because of this, cosine of COM A is sine of A. Cosine of COM PA is sine of PA. So you will change it to the sine of A sine of PA. So put in the calculation. So sine of PV is equal to sine of 68 now. And the sine of 64 and 29. So you'll get Let's see, calculate R. So 68. Let's see, calculate here. Sine of 68 here. So sine of 68 and sine of 64 to 9. Okay, 0.8367. Okay, so that means your PV is equal to sine inverse 0.638367 now, which is the answer here. You get 56 degrees, 48 minutes. Or another one is, because your sine line is 180 minus 36 degrees, 48 minutes here, which is 125. And how minutes here? And we know that we're going to reject the second one. Why is it reject the second one? Because you see that the larger the angle, the bigger the size, right? So PV is actually the smaller side. PV is the angle opposite PV is 68 degrees. The angle opposite 64:29 minutes is right angle, 90 degrees. So you know that PV cannot be more than 64 degrees, 29 minutes. So you reject. So the PV is 56 degrees, 48 minutes now. Okay, so this is actually PV here. This is actually 56 degrees, 48 minutes. So this PV here is 56 degrees, 48 minutes here. Okay, so this is 56 degrees, 48 minutes. So what does it mean? I know PV already. So let me look at this. Maybe I try to give you the overall picture here. So after you calculate this already. So now I want to show you what does it mean, all right? What do you know the latitude of V now? Okay, this is 56 degrees, 48 minutes. So you go back to earlier diagram. Okay, I know PV. So this PV here is 56 degrees. Okay, we have 56 degrees, 48 minutes here. As I have PV, right? 56 degrees, 48 minutes here. So what does it mean now? This latitude of B now. So latitude of B, okay, right here. So latitude of B okay, so we know that from North Pole to equator is 90 degrees. Okay, so you take 90 degrees minus the PA, right? PV. So take 90 degrees minus PV here, we get this is equal to 90 degree minus 56 degree, 48 minutes here. And then you can find that this is equal to 35 degree, 12 minutes. So this will give you, what is this angle now? This angle is 35 degree, 12 minutes.
So it's 33 degrees 12 minutes, not 35.
33 degree, okay, I made mistake, so 33 degree, thank you. So this is 33 degree, 12 minutes here. So this is 33 now. Right. So they'll give you the latitude of the vertex now. Vertex is here. Vertex here, right? So latitude of vertex is, that's why 33 degree 12 minutes. All right. So that's how you find latitude of vertex here. So I saw this first part right? So this latitude of vertex. Okay, then the other part is, what is the longitude of the vertex now? So in this way, you need to know where is this line. Where is this line here? Where is this line? Okay, where is this from joining the pole to the vertex? So I'm going to go back to my Napier view again to do calculation now. This time I think I need to calculate what is angle P now. Okay, so copy this and then find angle P now. So let me see whether I can get this. Yep, same. So I'll just copy this page first. And then go to the next page here. Okay, so I'm going to erase all the calculation from here. Accept diagram. And the views, I'm going to make P the target now. So this one is no longer now. Okay, this one is 50 degree here. Okay, so I know I want P. This is my target now. Okay, now I have two information about adjacent. So I can use this now on my adjacent. So the method to do this is first, always sine of meter part here. So sine of meter part is the product of tangent of adjacent. So let me move this diagram a bit here. Okay, product of tangent of adjacent. Okay, tangent of adjacent, just do it right. So tangent of adjacent. Okay. This is how it's supposed to be. So with that now, sine of P now, sine of P, but we call P now. Okay, because P is on the lower half of the sphere. And then now this product of tangent. So tangent here. So this tangent. It isn't one of those PB. PB is on top. No need to take column. So PB is on top. No need to take column. But the other one, you need to take column now because it's below now. So tangent com PA. But tangent com PA, we know that you can simplify. Of course, you use tangent 90 minus PA, but I can simplify it to tangent PV times 1 over tangent PA. Okay, tangent com PA is 1 over tangent PA. Yeah. So you actually got this. Although you don't need to do this, okay, because there are some people don't like this, but I always do this because it saves a lot of calculation. So tangent of com PA is 1 over tangent PA here. So put down the value here. So this actually tangent of PV is 56 degrees, 48 minutes. And then PA is 64 degrees, 29 minutes. After I calculate PA only. So now let's see what is actually sine com A. Sine com P is actually, sine of com P is actually cosine of P. Okay. Sine of com P become cosine of P now. You can switch to cosine. So it makes calculation easier. Okay, so let's do a calculation. What is this thing? So I have tangent of 56 degrees for the make A make I, so divide down. So tangent of for the 56 degrees, 48 minutes divided by tangent of 64 degrees, 29 minutes. Okay, so this will give you 0.729 0.7294. So P looking at now is cosine inverse 0.7294. And it will give you cosine inverse. The answer is 43.16, which convert a limit minute here. 46.43 okay, for the 3 degree 10 minutes. This is the angle P. So my final angle P is 43 degree 10 minutes. So this angle P, there's only one answer only. This answer is 43 degree 10 minutes. Okay, I find angle P already. Now I try to tell you what is the longitude of the point V. Okay, then I must go back to the earlier picture. Okay, so this is the earlier picture I have drawn for you here. So I know P is actually 43 degree. Yeah, right. So P is 43 degree and 10 minutes at P and the P here. So now I want to find out what is this location longitude. So A is 60 degree west, right? A is 60 degree west. So you move to the east. Okay, this is how they move west, 60 degree west. Move to the east, how much? So this longitude now, okay, let's write on here. So longitude of V. You start with 60 degree west. You move to the east by how much? The P is to tell you that how much they move, right? Angle P tell you that you have to move to the east. So subtract angle now for the 3 degree, 10 minutes. Okay, 60 degree west. Move to the east, how much you get? So get actually 16 degree and 50 minutes. And still on the west side. Right? So this is on the west side here. So you actually move from 60 degree, 60 degree, then you move to the west by 43 degree 10 minutes. And where is the location now? Then you point out V is 16 degree, 15 minutes, right? So this answers the whole question. Okay, so this is example 9. So I did not write everything on one page. So I show you how the things develop here. So that's why I think the people trying to say something. Let me see what is it. Okay, 60 for here. So do any mistake there? Okay. Okay. Let's see whether I make mistake here. Alright, so should be alright. Right. So 16 degree, 50 minutes. That's the given by answer. Let's see. There's actually an error here. Is there an error here? 4310. Okay, so okay, anything? Okay, so let me WhatsApp this to you. I think picture. Okay, WhatsApp this to you first, and maybe skipping here. So this is person working a little bit of not organized, okay, because I jump around the pages. So okay. Okay, so let me WhatsApp this one. First pick. Okay, let me jump around. Okay, this way applies the Napier rule. Next one. Yeah. Okay, so that is example 9. Already. Okay, so let's look at example 10. I'm not sure if I have time to finish for example 10. I hope I can finish. So I want to find the great circle distance and the initial cost from point A to point B. Okay, so how to do that? So as usual, you can draw a great circle first. Don't need to draw just to give you a better explanation. What is going on inside there? So I have, let me draw a big circle so that it actually has a big one here. So in North Pole is the equator, and there's a point A. Okay, so A is 55 for degree 10 north and 10 degree west. So A, okay, so let me see somewhere here. I try to put here so that you can see better. So this is actually A here, somewhere here, A. Okay, 52 degree, 51 degree here. So this is 51 degree, 10 minutes is point A. And this is actually at 10 degree west. Okay, I purpose at the top here so that I can see better. And then the point B is somewhere here now, going to the west. So let's see, this is the one. So this is actually 55 degrees west. And if we go further north now, this is point B. And this one is 52 degrees. So this angle is 52 now. Okay, the ship going from A to B. So we can join ship from A to B. So this is a B. Ship from A to B here. Okay, from A to B. So what we want to find is the great circle distance AB. Okay, and initial cost and final cost. So let's do it one at a time now. So great circle distance AB here. Initial cost and also the final cost. Initial cost only, okay, so for A to B. So the initial cost is 16. Measure from where I have not pole, right? Measure from not pole. So initial cost is actually this angle from not pole. So measure this angle, initial cost. Okay, for measure from not pole, direction not pole, and go towards the where it go, the direction go. This is the initial cost from A to B. Okay, so let's try to figure out more information before we draw a second now. In this case, there is no one angle here, so cannot use the Napier rule now, right? Just general sine law and cosine law. Okay, to find. First, let's try to figure out what is the co-latitude PA first. Okay, 1 and 5. PA. How to find the distance from P to A? So total angle from the north pole to the equator is 90 degrees. Okay. The co-latitude of A is called co-latitude. Of A is equal to 90 minus 51 degree 10 minutes, all right? So the pair equator, define over as PA here. So it's 90 degree minus 51 degree 10 minutes. And this is a 38 degree. And 50 minutes here. This is co-latitude of A. Okay, so that means I know PA now. Let's try to find PB also. Okay, PB co-latitude. P now is actually 90 degrees minus 52 degrees, right? The latitude of D is 52 degrees, so it's 90 minus